All right, in this next section, 7.5, we are going to look at the dot product. So we're going to use that, or we're going to define the dot product, and then we're going to use the dot product to find angles. So first, our definition of the dot product: if we have two vectors, v and w, the dot product, which we denote as just putting a dot between them, is defined as if I take my two x coordinates, multiply them together, and then take my two y coordinates, multiply them together, and then add those two values together. That'll get me the dot product. All right, so let's take a look at an example. So here's v and w. What I want to do is take my two x coordinates, multiply them together, so say v dot w is going to be 2 times 3 plus negative 3 times 4. So that'll be 6 minus 12 equals negative 6. So now notice the dot product is just a number. The dot product is not a vector. It's a scalar. Right? So all we're doing is multiplying the x components together, multiplying the y components together, and then adding them. All right? Let's do one other example. So on this one, we're given our vectors in this form. But remember, this just is the same as negative 3, 5, like that. And then this one is the same as 2, 3. So my dot product, v dot w, will be the two x's multiplied together, negative 3 times 2, plus the two y components multiplied together, 5 times 3. So that's negative 6 plus 15, which would be 9. All right. So we can use this dot product to find angles. All right. Here is our definition of an angle between two vectors. Right? If the dot product of two vectors is equal to their magnitudes multiplied together times the cosine of the angle in between them. Okay? So if we want to find the angle, we can solve this for cosine. Just divide both sides by the product of the magnitudes and say cosine of the angle between them is equal to the dot product divided by the product of their magnitudes. And then just taking the inverse cosine of each side, we get this formula for each angle in between a pair of vectors. Okay, so let's take a look at a couple of practice problems with this idea. Right? So first, in this problem, we're told v and w are two vectors and we're given their magnitudes. Okay, so we know that the magnitude of v is equal to 5 and the magnitude of w is equal to 7. And then in this case, we're told that the angle between them is 75 degrees. We want to find their dot product. Well, if we look back at that formula, the dot product is equal to the product of their magnitudes times cosine. Okay, so v dot w is equal to the magnitude of v times the magnitude of w times the cosine of the angle. So v dot w is equal to 5 times 7 times the cosine of 75 degrees. And we can put that into the calculator. 5 times 7 times cosine of 75 degrees. We get 9.058, so to the nearest tenth, 9.1. So the dot product here is 9.1. All right. The other possible setup we could have is solving for the angle, right? So here, I'm given these two angles. V is 2i plus 3j, W is negative 3i plus 4j. Okay, so we can write those in component form. Right? We can say V is 2, 3 like that, and W is negative 3, 4. So now, to find the angle between them, I need some information. Right? So our formula is, we're saying theta is equal to the inverse cosine of the dot product, so V dot W over the product of the magnitudes. So I need to get all of that information. I need the dot product, and I need each magnitude. So let's do the dot product first. V dot W will be the x components multiplied together, so 2 times negative 3 plus the y components multiplied together, so negative 6 plus 12 is positive 6. Then I need each magnitude. So the magnitude of V will be, remember we're just thinking about this in terms of Pythagorean theorem, so it'll be the square root of 2 squared plus 3 squared, which would be the square root of 4 plus 9, the square root of 13, and then the magnitude of W, use the same process, so the square root of negative 3 squared plus 4 squared, so that'll be 9 plus 16 is the square root of 25, which is just 5. So we have all the information we need now to plug in here. We can say theta is equal to the inverse cosine of 6 divided by the square root of 13 times 5. Now, I did not put the square root of 13 as a decimal because we want to leave that as an exact value. We want to get as close to the end result as possible. So we can put that into the calculator. Inverse cosine of 6 divided by the square root of 13. Make sure you get out of the square root, times 5. Close both parentheses. And we get that angle is 70.6 degrees. Okay, so let's think about what we just did graphically. Right? Let's pull up a graph. Okay, so what we're saying is if I take these two vectors, so we've got the vector 2, 3, so over 2 up 3, and then we've got the vector negative 3, 4. These two vectors here, the angle in between them is 70.6 degrees. That's what we just found out. Okay, so I know this video was a lot shorter than the last one. Some problems for you to try out of the book, and as always, send me any questions that you have.